So now we're going to talk about the differences between a hypothesis, a theory, and a law. So a hypothesis is an explanation to a question that you're asking. This is tested by experiment or continual observation. It can be disproven but cannot be proven true. So again, instead of saying we accept our null hypothesis or we accept our alternative, you say we fail to reject. We don't disprove it yet. So a theory summarizes a group of hypotheses. It's broader in scope. New hypotheses can be generated from it. It's supported by a massive body of evidence, but it never becomes a law. So a lot of people, especially because theory is such a used colloquialism, I think I pronounced that wrong. Oh well. Um, they don't understand that a scientific theory is actually a really strong body of evidence, but it doesn't ever become a law. There is a difference between the two. So a law is usually a mathematical formula. So for example, Newton's law of gravity, which is why that picture is the apples, it describes an observation, not how or why. It is generally accepted to be true and universal. It's a basis for scientific method. We actually don't have that many laws, especially when we get to biology. There are quite a few, but not as many as you would think. So experiments are started with an observation and a hypothesis. So it uses a control group, either positive and or negative, or both in experimental groups. So well-designed experiments should include an independent variable, a dependent variable, a control group, positive and or negative. So it can be just a positive one or it can be just a negative one, or it can be both. Constant, so these are things that don't change, and number of trials. So again, just because of the limitations of class, lots of times we can't do 3 trials, but no, that's not actually good science. You need to do minimum of 3, upwards of like hundreds. So a variable is something that is changed in the experiment. So we're looking at the experiment here. So we changed what the electrodes are. One is copper, one is probably zinc. So how does that change the electrical current? And versus a constant, something that doesn't change throughout the experiment. So for example, if you're looking at this picture, it's the number of beans per pot is a constant, and the pots are the same. So you're not testing to see if a plastic pot is better than a ceramic pot. The pots are exactly the same. The number of beans are exactly the same, because that's not what you're testing. So you want to make sure that your constant, that couldn't have an effect. A constant is not the same as a control, though. So again, what an independent variable is, it's the one factor. So you want to make sure that it's very controlled. Only one thing is changing. So for example, it's the amount of water. So not the number of beans, not the pot, not where they are, not sunlight, nothing else. The only thing that's changing is the amount of water. And the dependent is, it depends on the independent. So here, what they're testing is how many beans will sprout versus depending on their water.